Welcome back to the deep dive. I want to start today by admitting something. It's a feeling I think a lot of us who follow this stuff have, but we don't really say it out loud
Oh,
because well, it sounds kind of ungrateful. We're living in this absolute golden age of physics. We've got the Standard Model, we have general relativity, we have these incredible telescopes looking back to the very dawn of time.
it's an embarrassment of riches, for sure. The amount of data we have is just, it's staggering.
It is.
Yeah.
It really is. But here's the problem. And it's a problem that, honestly, it keeps me up at night sometimes. I trust the math. I really, truly do. If you show me the equations, for quantum field theory, I can look at them and nod and go, okay, that predicts the magnetic moment of the electron to 12 decimal places. It's unbelievable precision.
It's the most successful theory in human history by that metric.
Right. But then if you ask me to close my eyes and actually visualize what's happening, to get a mental picture of what reality is doing,
It all just falls apart.
it's not just that it falls apart, it's worse. The picture is a completely schizophrenic mess.
Mm.
We're forced to use these two totally different languages to describe what should be one single reality.
Okay, lay them out.
On the one hand, you have the quantum world,
Mm.
the small stuff. And the way we talk about that, it's a ghost story. It's all about things popping in and out of existence,
Yeah.
spooky action at a distance, cats that are somehow both dead and alive until an observer comes along and looks at them.
The magical observe, right?
And then on the other side, you have the big stuff.
Mhm.
You have cosmology. And that story is, well, it's basically a Michael Bay movie.
Huh. I like that.
It's the Big Bang. It's
Yeah.
all about violence and explosions and debris flying out into this empty void. So we're stuck in this really weird limbo where the absolute foundation of reality is a ghost story and the history of reality is an action movie. And
Yeah.
I don't buy it. I don't believe the universe is that disjointed.
You have put your finger on the exact problem. That feeling you're describing, that sense that the math is perfect, but the story we tell ourselves feels broken.
Yeah.
That's what today's source material calls conceptual dissonance.
Conceptual dissonance. I like that phrase. It sounds painful.
It is painful. It's the friction you feel between a perfect set of equations and a really terrible set of intuitions. And that is exactly what we're going to be tackling today. We're doing a deep dive into a really fascinating paper. It's titled Quantum Condensation as a Unifying Language, and it's by Lev Nemotin, PhD, from a company called N5 Digital.
Okay, now, right off the bat, before our listeners' eyes glaze over and they think, oh, great, here we go, another theory of everything from some guy in his garage who thinks Einstein was wrong, we need to be crystal clear about the mission here.
Yes, this is a crucial distinction, and we need to underline it. Nemotin is not proposing new physics.
Not at all.
He's not saying the Standard Model is wrong. He isn't saying we need to add a new particle or that dark matter is actually, made of cheese or something.
He's not challenging the data.
Not one bit. He's effectively saying, look, the math is fine. The equations are doing their job perfectly, but the English language, the metaphors we're using to translate that math into human thought, those are broken.
So this is like an intervention for our collective intuition.
That's a perfect way to put it. He's proposing a new interpretive language. He essentially wants to wipe the slate clean of all the ghosts and the explosions and replace them with a single unifying metaphor. A metaphor that can work for the tiniest electron and the entire universe all at the same time.
And that central metaphor is condensation.
Quantum condensation, to be precise.
Which I have to admit, on the surface, it sounds a little simple. Condensation is something I see on my bathroom mirror every morning. You're seriously telling me that same everyday process can explain the birth of the cosmos?
That is precisely the claim. And look, I was skeptical at first too. It sounds almost too mundane. But the deeper you get into this paper, the more you realize that this concept of condensation, or more broadly, the physics of phase transitions, it's an incredibly powerful tool.
How so?
Because it's all about how something diffuse and high energy and unstructured, how that system settles into something that's localized, low energy, and structured. And if you think about it, that's the story of everything.
Okay, I'm intrigued. I'm willing to be convinced. But to really appreciate the solution he's offering, I think we need to spend a bit more time dissecting the problem. We talked about the ghost story and the action movie. But why are they so disconnected? Why do we even teach physics in these separate silos?
It's mostly a historical accident, I think. But just consider how the average, well-informed person encounters physics. It usually comes at you in 3 completely distinct domains.
Right. Okay, so domain 1, the laboratory.
The lab. This is the microscopic world. It's where we deal with individual particles, wave functions, the double-slit experiment. In this world, the dominant narrative is all about probability.
Everything is just a smear of possibility.
Exactly. Nothing is really real in a solid sense until it smacks into a detector and makes a click. It's the realm of potential.
Then you've got domain 2,
Mm.
which is, let's call it the philosophy seminar.
This is where things get really messy. This is where everyone argues about the so-called measurement problem. You know, if the Schrödinger equation says the wave function just evolves smoothly and linearly, why do we always see single, definite outcomes in our experiments?
And this is where the really wild ideas come in. Does consciousness cause the collapse? Is that what's happening?
This is where all the woo-woo, as you
Yeah.
said, enters the chat. It's a philosophical minefield.
And then finally, domain 3, cosmology. The big picture.
Yeah.
The stuff you see on the History Channel.
Exactly.
Right.
And in cosmology, the narrative is totally different again. It's all about gravity and expansion and that one big event, the bang. The problem Neymotin points out so clearly is that these three domains, they feel like they're from different genres of film.
Right.
If you try to take the logic of the Big Bang, this idea of debris scattering outward into a void, and you try to apply that to a single electron in a lab, it makes absolutely no sense.
Not at all.
And if you do the reverse, if you take the logic of the observer from the philosophy seminar, this idea that a conscious mind collapses reality, and you try to apply that to the early universe, well, who was observing the Big Bang?
Was it God? Was it some advanced alien race? It gets metaphysical really, really fast.
It gets messy. So the common puzzle, the thread that actually connects all three of these scales, is a really simple question when you boil it down.
And what's that?
How does something that starts out diffuse and, smeared out become stable, persistent, and solid?
That is the core question, isn't it? From the quantum wave to the classical world. From the energy of the early universe to the galaxies we see today.
That is the fundamental nut we are trying to crack. And in the standard view, for the quantum stuff, we use that word, collapse.
The wave function collapse.
I have always hated that word, collapse. It sounds so negative. It sounds like a failure, like a bridge falling down or a building being demolished.
Or a balloon popping. It implies that a structure is being destroyed. Or, even worse, the standard interpretation implies that the reality wasn't even there to begin with.
Right, that the electron is just a ghost or a mathematical probability until you looked at it. It's a story that puts the human observer right at the center of the universe.
I look at look, therefore it is.
It's totally narcissistic.
It's anthropocentric magic.
Yeah.
And then for the universe, we use the word bang, which implies chaos, shrapnel, entropy increasing violently and destructively. Neymotin's whole argument is that both of these core metaphors, collapse and bang, they trigger this conceptual dissonance because they describe either violence or magic. And his goal is to replace them with something physical.
Exactly. He wants to heal that rift in our intuition.
Okay, let's do it. Let's heal the rift. The paper breaks this down beautifully into what he calls one story, 3 scales. So I think we should just walk through it, starting from the very bottom and working our way up. Let's start with scale 1, the particle.
The basement of reality, the quantum realm.
So paint the picture for me. In this new framework from Lev Neymotin, we are throwing out the word collapse. We're not using it anymore. What are we replacing it with?
We are replacing it with a dynamical phase transition. And to get the feel for that, he wants us to think about something really simple. Water vapor. Imagine you're in a sauna. The air is thick, it's full of water, but it's in its gas form. It's steam.
Okay. High energy, molecules moving fast, bouncing all over the place.
And critically, it is delocalized. You can't just point to a specific spot in the air and say, aha, the water drop is right there. It doesn't work that way. The water molecules are spread throughout the volume of the room. But, and this is the absolute key, that steam is real.
Right, it's not imaginary. It'll burn you.
It will burn you. It has mass, it has energy, it carries heat. It isn't potential water, it is actual water, just in a high energy, spread out state.
Okay, so it's not a ghost of water. It's just spread out water. I'm with you.
Now, Neymotin says, treat the wave function exactly like that vapor. In standard quantum mechanics, we describe particles as these waves of probability. And usually people hear probability and think it's just a mathematical fiction, a tool for calculation.
A statement of our ignorance.
Exactly. But what if you take it physically? What if you think of the wave function as a real, physical, delocalized field? It's smeared out energy, just like the steam.
So the electron isn't a tiny ball, it's a cloud, an energy cloud.
It's a cloud of possibility, yes. Now let's go back to the sauna. What happens if that cloud of hot steam hits a cold window pane?
It beads up, it condenses, it turns into liquid water, and you get a distinct droplet at a specific spot on the glass.
And why does that happen? What's the physics?
Well, it's thermodynamics, right? The gas loses energy to the colder glass. It can no longer maintain that high energy spread out state,
Yeah.
so it has to settle down into a lower energy state, which is a liquid.
Precisely. It condenses.
Yeah.
Now, notice what didn't happen in that story. The window didn't observe the steam in a conscious way.
No.
The window didn't have a PhD. There was no wizard in the room casting a spell. And the steam didn't collapse in the sense of being destroyed or failing. It underwent a phase transition. It transitioned from a delocalized state, the vapor, to a localized state, the droplet, purely because of a physical interaction with its environment.
So to apply this analogy directly to the electron.
The electron cloud, this wave function, it flies along and it hits a detector. Or maybe it interacts with a photon or passes through a magnetic field. That interaction is the cold window.
It's the environmental trigger.
It's the trigger the electron system couples to the environment. And in that moment, it becomes unstable in its spread out form. It has to shed energy or reorganize itself to find a more stable configuration. So it condenses into a localized point.
That really does strip all the spookiness right out of it, doesn't it?
That is the entire goal. In this new language, localization isn't a revelation of a position that was secretly there all along. It's the formation of a position.
Hold on. I want to dig into that distinction because that feels really important. Revelation versus formation.
It's a crucial distinction. In the standard, sort of classical-minded view, people often think the particle was always hiding at point A, and our measurement just, turned on the light so we could see it.
The hidden variables idea.
Right, but Bell's theorem and countless experiments have shown that's almost certainly not true. There are no pre-existing hidden variables. So then people swing to the opposite extreme, to the magic view. The particle was literally nowhere, and our consciousness, our act of looking, forced it into being somewhere.
The ghost in the machine.
Nemotin's view is the third path, the physical path. The particle was everywhere in its cloud-like state, just like the vapor. The interaction with the detector caused it to form at point A.
Just like the droplet forms on the glass. The droplet
What?
wasn't hiding in the steam.
Exactly. The droplet was created by the physical process of condensation. It's an emergent property of the interaction.
Okay, so it forms at a specific spot, not because of some magical intent, but because of, what? Random fluctuations. Tiny imperfections in the detector.
Yes, that's it. It's a process called symmetry breaking. When steam condenses on a window, the exact spot where the first droplet forms is determined by microscopic fluctuations. A tiny temperature difference, a microscopic scratch on the glass, a dust particle. It's probabilistic, for sure. We can't predict the exact spot, but the process itself is purely physical. It's just following the laws of thermodynamics and energy conservation.
So we can finally fire the observer. We don't need a conscious being anymore. We just need an environment.
We just need an environment that can act as a heat sink, something to absorb the excess energy and, crucially, the information from the system. The electron condenses because it must physically stabilize when it interacts. This view effectively kills the magic observer idea without changing a single line of the Schrödinger equation.
The equation still describes the evolution of the wave, the vapor.
And the condensation metaphor describes the mechanism of interaction the moment it hits the glass.
It feels so much more robust and physical. I can touch condensation. I can understand the concept of cooling. I can't really understand collapse.
The mantra here is weird, but physical.
Yeah.
It's okay for the quantum world to be strange, but it shouldn't require magic.
But, okay, this is where my skepticism starts to kick in again just a little bit. Condensation, in my experience, is usually reversible.
Right.
If I heat up the window, the water droplet turns back into steam. It evaporates.
Right.
But in physics, and certainly in my daily life, things don't seem to reverse like that.
Mm-hmm.
If I perform a measurement on an electron, or if I drop my coffee mug on the floor and it shatters, it stays shattered. Reality feels sticky. It feels permanent.
You have just hit on the most crucial transition in the whole theory. This is where we move from scale 1 to scale 2. This is the transition from a fleeting particle event to a permanent record. Or, to put it another way, how a quantum event becomes a classical fact.
Because that's the real mystery when you get down to it, isn't it? The quantum world is described by equations that are fluid and reversible in time. Our world, the classical world, is rigid and historical. There's an arrow of time. How do we cross that bridge?
Nemotin approaches this by introducing the concept of quantum uncondensation.
Which is evaporation, basically, going back to steam.
In essence, yes. He asks the question you just asked. Why don't we see the droplet spontaneously turn back into vapor? Why don't we see the broken mug reassemble itself and fly back up into my hand? In principle, the fundamental laws of physics are time-symmetric. You could run the movie backward, and it would still obey all the rules, but we never ever see that happen. Why not?
Well, the standard textbook answer is entropy, the second law of thermodynamics. You always move toward a state of greater disorder. A shattered mug is more disordered than a whole one.
That's the textbook answer, yes, but it can feel a bit abstract. What does disorder really mean? Nemotin grounds this whole concept in information theory, and he introduces a term that I think is maybe the strongest technical contribution of the entire paper: the record radius.
For record radius. Okay, you have to break that down for us.
Let's go back to our electron condensing on a detector screen. Ping. It hits a specific spot. What happens in that instant? It creates a flash of light, right? Photons go flying off. It also heats up the screen at that point, just a tiny bit. That means it creates vibrations in the material, which we call phonons. It probably displaces a few air molecules that were nearby.
So it's not a silent event. It creates a disturbance, a ripple in its immediate surroundings.
It creates a record. All the information about that event, the fact that the electron hit right here at this time, is now encoded in the physical state of those photons that heat those air molecules, and all those carriers of information are now moving away from the event at high speed.
So the news of the event is spreading outward.
It is literally rippling out into the universe. The photons are moving away at the speed of light. The sound, the vibration, moves away at the speed of sound. The record radius is simply the physical distance that information has traveled from the point of condensation. After 1 second, the photonic record has a radius of about 300,000 kilometers.
Wow.
Now here's the kicker. To uncondense that event, to turn that droplet back into vapor, or to make the electron unhit the screen, you would need to reverse the trajectories of every single one of those information carriers.
You'd have to catch every single photon.
Every photon, including the ones that are now past the moon. You'd have to catch every air molecule that got nudged. You'd have to perfectly collect every bit of that heat energy, that vibration, and you'd have to focus all of it with perfect timing and precision back onto that single point of origin.
Which is, I mean, that's not just hard, it's effectively impossible.
It is thermodynamically prohibitive. It's not a violation of physical law, it's an issue of information cost. The universe is hyper-efficient at dispersing information. It loves to gossip. It tells the environment what happened immediately and in every direction. To erase a fact, you have to find and silence every single piece of that gossip.
So reality becomes irreversible, what we call the arrow of time, not because the laws of physics forbid reversal, but because the record radius expands so ridiculously fast that we can never catch up to all the information to put it back in the box.
Exactly. A fact, what we call classical reality, is just a quantum condensation whose record radius has expanded so far, so fast, that for all practical purposes, it cannot be undone.
This is starting to remind me a little bit of the many worlds interpretation where they talk about decoherence. Is this a related idea?
It is deeply, deeply related. Decoherence is the proper mathematical description of how a quantum system's wave function gets entangled with the environment and loses its clean coherence. What Nemotin is doing here is giving us a powerful visual language for decoherence.
He's giving it a physical metaphor.
Yes. Instead of just saying the phase angles of the wave function got scrambled with the environment, which is abstract, he's saying the information condensed and the record radius expanded. It makes the concept of decoherence spatial and tangible. You can picture it.
And picturing it, I think, brings us to the most famous and most misunderstood animal in all of physics.
Schrödinger's poor, abused cat.
The cat. So in the standard thought experiment, the cat is in a sealed box with a radioactive atom. If the atom decays, a mechanism releases poison, and the cat dies. If it doesn't decay, the cat lives.
Simple enough.
But quantum mechanics says the atom, until measured, is in a superposition of both decayed and not decayed. Therefore, by logical extension, the cat must be in a superposition of dead and alive.
Until you, the heroic observer, open the box and collapse the state.
Right. Which has always sounded completely absurd. The idea that I am the god of cats and my gaze determines its mortality, it's the ultimate example of the magic observer problem. How does Nemotin's condensation framework fix this paradox?
He argues that the paradox is a category error from the very beginning. He says we are treating the cat as if it's a single, isolated subatomic particle, but it's not. A cat is a macroscopic, warm, living object. Or, in his fantastic terminology, a cat is an incessant producer of environmental records.
Incessant producer of environmental records. I love that.
Think about it from a thermodynamic perspective. A cat is a biological engine. It has a body temperature of roughly 38 degrees Celsius or 101 Fahrenheit. That means it is constantly radiating infrared photons in all directions, like a fuzzy, four-legged light bulb.
It's glowing in the dark, in infrared.
Constantly. It's also breathing, which creates pressure waves sound in the air inside the box. Its heart is beating, which creates tiny vibrations in the floor of the box.
But what if the box is perfectly sealed and soundproof?
Even then, unless you have a box that is a perfect vacuum insert, perfectly reflective on the inside, suspended in a zero-gravity void at absolute zero temperature, the cat is interacting with its environment. The walls of the box are absorbing its body heat. The tiny gravitational field of the cat is pulling on the box, on the Earth, on the moon.
So the cat is constantly leaking information about its state into its immediate surroundings.
Constantly and massively. The record radius of the cat's state of being alive or dead is expanding continuously. If the cat dies, its body temperature starts to drop. The pattern of infrared radiation hitting the walls of the box changes instantly. The vibration of the heartbeat stops. The sound of its breathing stops. The universe, meaning the physical environment immediately surrounding the cat, knows the state of the cat on a time scale of nanoseconds.
So the grand skooky superposition of dead and alive never even gets off the ground.
It breaks down almost instantly. The cat condenses its own reality continuously because it is so strongly coupled to its environment. By the time you, the human, walk into the room and decide to open the box, you are just reading a factual record that was written and finalized hours ago. You aren't collapsing anything. You're just the last person to find out the news.
That really puts the observer back in their proper place. We aren't the creators of reality. We are, at best, readers of the records.
We are late to the party. The condensation happened long before we arrived.
I find that incredibly satisfying as an explanation.
Yeah.
It connects the weird quantum stuff to the normal classical world just by scaling up the amount of interaction. A single particle interacts very weakly, so it can stay in that ghostly vapor state for a while. A cat interacts a whole lot, so it's a solid fact from moment to moment.
It all just boils down to the density of the records being produced.
Okay, so we've done the small scale with the particle. We've done the medium human scale with the record and the cat. Now we have to zoom all the way out. We have to go to the largest scale possible, the scale where my intuition truly, truly struggles. The origin.
Scale 3, the universe.
We're talking about the Big Bang. Now, you mentioned at the very beginning that Neymotin has a real problem with the term Big Bang.
He does. And, historically, the term was actually meant as an insult. It was coined by the astronomer Fred Hoyle, who was a big proponent of the rival steady-state theory. He was on the radio mocking this new idea of an expanding universe by calling it the Big Bang.
And the name just stuck.
The name stuck. And unfortunately, that name carries a lot of misleading baggage. It sounds like a weapon, a bomb, a grenade going off. It immediately conjures an image of a single center point, with shrapnel and debris flying outward into a pre-existing empty space. That is the mental image that almost everyone has, a cosmic debris field.
But every physicist will tell you that's the wrong picture. It wasn't an explosion in space. It was an expansion of space itself.
Right. But expansion of space is a very abstract, very difficult thing to visualize. Explosion is easy, so our intuition defaults to the simpler but wrong violent metaphor. Neymotin wants to replace it with the QC bang. The quantum condensation bang.
The QC bang. Okay, walk me through the imagery here. How is the birth of our entire universe like condensation?
He asks us to imagine the very early universe not as a tiny, dense ball of debris, but as a vast, undifferentiated field of pure, high-energy potential. Think of it as a universal, superheated vapor, a cosmic steam.
Okay, no structure, no particles, just hot, uniform potential.
Exactly. Now, as the universe expands, it cools. This is standard accepted cosmology. But instead of thinking of debris flying apart as it cools, think of it in terms of phase transitions. As the universe cools past certain critical temperatures, the fundamental energy fields condense.
Like water vapor cooling and freezing directly into ice crystals.
That is a perfect analogy. When water freezes, it undergoes a phase transition. It breaks symmetry. Liquid water looks the same in all directions, but an ice crystal has specific axes and a definite structure. Neymotin argues we should view the entire origin story of matter, the separation of the fundamental forces, the formation of the first protons and neutrons, as a cascade of these condensations. Energy reorganizing itself into new, more stable, more structured states because the ambient temperature dropped.
So the universe didn't explode into existence.
Right.
It settled into existence.
It precipitated. That is a much calmer and I think a much more physically accurate word for it. Matter precipitated out of the primordial energy field like rain falling from a cooling cloud.
Wow. That completely changes the emotional tone of the origin story. It's not a story of violence anymore.
Not at all. It moves from a narrative of destruction and chaos to a narrative of organization, structure, and settling.
In the paper, he includes this visualization that I found incredibly helpful. He calls it the hourglass. Could you describe that for us? Because it really ties it all together.
Yes, the hourglass is the visual anchor for the whole theory. He asks you to picture a classic hourglass, but lying on its side.
Okay, got it.
On the left side, you have a wide glass bubble. He labels that bubble possibility. That is the vapor. That is the quantum wave function. That is the high-energy, undifferentiated early universe. It's diffuse, it's symmetric, it's full of potential.
Then all of that possibility funnels down into the narrow part in the middle.
Into the neck, the pinch point. That narrow neck represents the condensation event. That is the moment of interaction. That is the measurement. That's the moment the temperature drops below a critical point.
The record is created right there in the pinch.
Exactly. And then on the right side, the hourglass opens up again into another wide bubble. But this bubble on the right is fundamentally different. It's not possibility anymore. He labels it structure. This is the complex classical universe we see around us. It's the condensed droplet. It's the galaxies, the planets, the DNA.
So the arrow of time, the flow of reality, is the flow of energy through the neck of that hourglass. From a state of vapor through the act of condensation into a state of structure.
Precisely. And the real beauty of Neymotin's argument is that this single, simple shape applies to everything, at every scale. The electron hitting the detector screen goes through the hourglass. The cat living or dying in the box goes through the hourglass. The entire universe cooling after the initial hot state goes through the hourglass. It's one single geometric logic for all of reality.
It's like a fractal geometry. The same fundamental pattern repeating at every scale.
What changes is the scale, not the logic. That is the great unifying principle of this language.
Now, I feel like I have to push back again just for the sake of rigor. You said at the beginning that Neymotin isn't changing the math, but we have very successful mathematical theories for the Big Bang. We have inflation. We have the lambda CDM model. Does this condensation idea replace any of those?
No, absolutely not. And this is where the paper shows a level of restraint and modesty that I really appreciate. He states very explicitly something to the effect of, the equations do not need our help. Inflationary theory does a fantastic job explaining the rapid expansion. General relativity handles the gravity perfectly. He's not trying to recalculate the Hubble constant with this idea.
So what's the utility then? I mean, if the numbers all come out the same, why bother renaming expansion to condensation?
This brings us right to the synthesis of the whole argument, the philosophy of science part. Why does interpretation matter at all?
Yeah. If I'm calculating the trajectory of a rocket to Mars, does it really matter if I think of gravity as a bird or a rock, as long as the numbers work and my rocket doesn't miss?
In the short term, for a specific calculation, maybe not. But in the long term, for the progress of science as a whole.
Yes, absolutely. Because the metaphors we use dictate the kinds of questions we ask.
Okay, give me an example.
Let's go back to the atom. For a very long time, the dominant metaphor was the solar system model. The nucleus is the sun, and the electrons are tiny planets orbiting it.
Right. That's the picture you still see in every high school textbook, a little Bohr model.
And it is a terrible, terrible metaphor. Because according to classical physics, an orbiting electrical charge should be constantly radiating away energy. It should spiral into the nucleus in a fraction of a second. If you take the solar system metaphor literally, atoms shouldn't be stable. The universe shouldn't exist.
So the metaphor leads you directly to a contradiction with reality. It leads you to ask bad questions. Students look at that model and they ask, so how fast is the electron spinning? Or what color is the electron? Those are nonsense questions in a quantum context. But if you change the metaphor, if you start to think of the electron as a standing wave, like a plucked guitar string, suddenly the questions you ask change.
You don't ask about position, you ask about vibration.
You ask about harmonics, you ask about energy levels and modes. And those are the questions that lead you to the correct physics of quantum mechanics.
So Neymotin is basically arguing that collapse and bang our modern-day solar system model. They're useful up to a point, but ultimately they're misleading us and making us ask the wrong questions.
That's it exactly. If you think of quantum measurement as magic observation, you can waste decades arguing about the role of consciousness. But if you think of it as thermodynamic condensation, you start asking much more practical questions about efficient information transfer. You start asking about how to engineer environments to prevent condensation, to preserve delicate quantum states.
Which is directly relevant for building a quantum computer.
It is massive for quantum computing. The single biggest engineering challenge in quantum computing is fighting decoherence. It's about keeping your qubits from condensing into boring old classical facts before you're done with your calculation. If you view that problem through the lens of Neymotin's record radius, you might start to develop entirely new ways to shield information from leaking out. You stop trying to fight a magical collapse and you start trying to insulate a physical phase transition.
It changes the entire engineering mindset.
Completely. And you can do the same for cosmology. If you stop looking for the center of the explosion and you start looking for things like phase boundaries or condensation defects in the early universe, you might interpret the patterns in the cosmic microwave background radiation in a totally new light. The math stays the same, but the search parameters for new discoveries can shift.
It's really about cognitive ease, isn't it? If the story you tell yourself fundamentally contradicts the math, your brain has to spend half its energy just fighting that dissonance. If the story and the math are aligned, you can think faster and more clearly.
Alignment. That is the key word from the paper. We need our mental movies to match our mathematical scripts. Particles are excitations, not objects. Localization is interaction-driven formation, not observer magic. Classicality is the stability of records. Cosmology is large-scale organization, not a field of debris.
You know, just taking a step back from the details, this whole conversation has had a kind of a weird effect on me. Usually when we do these deep dives into quantum physics or the sheer vastness of the universe, I end up feeling small. I feel alienated.
The existential dread of the void, it's a common feeling.
Yeah, exactly. This feeling that there's this cold, mechanical, spooky universe out there, and I'm just some insignificant accidental glitch in the system. But this condensation view, it feels surprisingly biological. It feels integrated.
How do you mean?
Well, if the universe isn't a random debris field, but is instead a process of settling and organization, and if I'm not some special outside observer, but instead I'm just a very dense, very complex bundle of records, it feels like I'm part of the crystal as it's growing.
That is a really beautiful image.
I'm not watching the universe from the outside. I am the universe condensing.
You are. You are a standing wave of condensed energy. You're a localized stabilization of the very same fundamental fields that make up the stars and the vacuum between them. The only difference between you and a rock and a star is the density and complexity of the information, of the records.
It sort of dissolves that hard barrier between subject and object, between the observer and the observed.
Which has been the central headache of Western philosophy for 3,000 years. Maybe the solution was hiding in thermodynamics all along.
It usually is, isn't it?
It usually is.
Wow. We have covered a lot of ground today. We started with that deep frustration, the intuition gap, the ghost story versus the action movie. And we walked through Lev Neymotin's really elegant proposal to use quantum condensation as a unifying language.
We saw how a single particle condenses like vapor on a cold glass, which completely removes the need for a magical wizard to make it real.
Then we saw how a record locks that reality into place, not because it's magically permanent, but because the record radius expands so fast, it creates an information cost that's just too high to ever pay back. And in doing so, we finally saved Schrödinger's cat by admitting it's a heat engine, not a quantum coin flip.
And finally, we reframed the entire story of the Big Bang as a QC bang, a global cooling and settling process, a precipitation of structure, rather than a violent, chaotic detonation.
It is a lot to take in, but I think the final takeaway for you, for the listener, is actually pretty grounded and personal.
What's your final thought on it?
The paper ends with a sentiment that I really appreciated. Neymotin is humble enough to admit that this might not be the truth with a capital T. Physics is always just a map. It's never the territory itself. But he argues, and I think he's right, that this is a better map. It's a more useful, more intuitive map.
A map that doesn't require you to believe in magic to read it.
Exactly. So here's my final provocative thought for you as you're listening to this right now. I want you to look around the room you're in, look at your own hand, look at the road ahead of you if you're driving.
And don't see them as static dead objects.
Right. Try to shift your vision just for a moment. Don't see things. See energy. See a universal vapor that has managed to cool down, to settle, and to condense just enough to become stable for a little while. See the records radiating off of everything, the light, the heat, the sound, the information.
See the ongoing condensation.
You aren't just a passive observer of the universe. You are a stabilized, complex, thinking part of its ongoing condensation. You aren't separate from it. You are the universe, cooling down and waking up.
I can't top that. That's a perfect place to end.
Thanks for diving deep with us today. We'll see you next time.